Okay, so another little video to try and help explain what is a pretty tricky question, this one. We've got the equation of a tangent to the curve x equals cosine 2y plus pi. It's annoying because it's an x equals cosine in terms of y, but Sumana put us on the right track. Rather than trying to rearrange it and get dy dx, let's find dx dy and go from there. So that's what we're going to do first. We've got the cosine of 2y plus pi. Dx dy, derivative of cosine of anything, is negative sine of that thing, so we've got negative sine 2y plus pi, and of course we've got to do the derivative of the inside brackets with our chain rule, so the derivative of 2y is 2, negative 2 sine 2y plus pi. Hope you're enjoying the washing machine in the background. From there we've got a choice. We can simplify it. We don't need to simplify it, it'll work if we don't, but I'm going to, just to make it a little bit easier. So sine of 2y plus pi, why did that simplify to just negative sine 2y, which would then become 2 sine 2y? Let's have a look. Best friend in maths, unit circle. If you imagine any angle, the sine of that is the y coordinate. If I add pi to that angle, so I've now got an angle pi plus theta, you can instantly see the y coordinate is going to be the same magnitude, but it's going to have the opposite sign. If you imagine I started with a negative 1, say something down in the 4th quadrant, if I add pi to that, I end up in quadrant 2, and again the y coordinate is now the negative of what it used to be, so the negative of a negative would be positive. So that's what I'm going to do here. Sine of 2y plus pi is negative sine 2y. There's already a negative out the front, so I end up with 2 sine 2y. Now we're getting somewhere. They've told us a point to sub in. The point they want us to sub in is the point 0 pi over 4. This is in terms of y, so we've got to sub in the pi over 4, not the 0. Be careful when you do that. So I've got dx dy when y equals pi over 4 is 2 sine and 2 times pi over 4, pi over 2. Like we've got our best friend drawn over here already. Sine of pi over 2 up the top, the y coordinate's 1. So I've got dx dy equals 2 times 1, whoop, dy getting carried away, which is 2. Obviously then, to find dy dx, it's the reciprocal. Reciprocal of 2 is 1/2. We're getting somewhere. We've got a point, we've got the gradient of the line. I'm going to go with the gradient point form. You can use y equals mx plus c, it doesn't matter. I like the gradient point form, so that's what I'm going to do. So y minus the y coordinate is pi over 4 equals 1/2 x minus, and the x coordinate we know is 0, so that's not too bad. Simplify that and we've got y equals 1/2 x plus pi over 4. We can fill in the answers. A is 1, B is 2, C is pi, and D is 4. Did we get it right though? It's probably a 6-mark question. You've probably got a couple of minutes up your sleeve. Quickly on your calculator, have a sketch and see how it looks. Bit tricky in this one because the sketch is in terms of y. Luckily I've got Desmos. I'm going to check it out on that. I've already got cosine of 2y plus pi drawn for me. What's the equation we need to sub in? 1/2 x plus pi on 4. Let's give it a go. Y equals 1/2, push across, or it'll put the x in the denominator, x plus pi divided by 4. Looks right. Is it going to look right when I get rid of the screen? Doesn't that look beautiful? We know we got it right. I hope that helps you out. Cheers.